Okay, cool. So what are agent frameworks or LMM agent systems? I think they're kind of called a couple different things. The basically they're like when these different you typically LLMs, but they could be LMMs, play different roles in a some kind of like problem solving task. And like an agent would be like one of these LMMs or LLMs. And usually the way you define an agent is it's just an LLM with some kind of prompt. So it could be like your job is to decompose this task into subtasks, and that's one agent's job. And then another agent is like, your job is to take this question and find a tool that you can use to solve the question. There's actually a really good post by Lillian Wang. Um, she's got a couple, actually, she has a ton of great posts here, but I like this one. Gives like a good overview and kind of maybe a high level idea of what the main components are in these systems, and also points to a lot of really good papers, one of which we'll go over. But the way she defines it is kind of like planning. So how do you do sort of like sub goals or decomposition? She also loops in like reflection and refinement into that category. So can it like criticize itself and like improve on itself? Memory, which we'll go over. So can it maybe store memory from previous iterations? And then finally, tool usage, which is definitely something we're going to cover, um, which is like, can you call an external API to solve a task? Um, okay, so the first paper here is called Reflexion. So this kind of is maybe goes in the planning section because it's reflection. And the idea here is that you have this agent framework that can interact with an environment. Maybe it's like an API call. Maybe you're playing like a game where you're like, I don't know, walking through some system and you can interact with objects and stuff. So you have this agent that can interact with the world. And when you interact with the world, you get some feedback. You maybe call an API and it fails. And then it has this sort of self-reflection agent that's going to take that sort of observational feedback plus what the action agent did and self-reflect on that so it can improve later on. And this helps a lot with like decision making or reasoning, or you can imagine programming, like you execute some code, it fails, you got to look at the error and like figure out how to like edit the code to improve it. Um, so at a high level, it's got these sort of three systems. These aren't necessarily all individual LLMs, they're just sort of components of the system. So, like I said, you have the actor. So, user comes in and they're like, "Hey, um, I want to, count the dogs in this photo." So the actor is going to say, "Okay, maybe I'm going to go in and call this dog counting API," and it tries to make the call to the API and it fails. So that's your like observation or your reward there. And then this evaluator is going to come in and like give some kind of ranking to how well the actor did. So it's going to rate it. Um, I think they say they rate it on like a scale of 1 to 5 or something. Um, how well that actor did on that task. The evaluator doesn't necessarily need to be an LLM though. You could have some other way of collecting that information. And then the self-reflection LLM is going to take in that info, and it's going to like review itself on how well it did on that task and kind of think of ways to improve it. And then it's going to store that as a text prompt into kind of this like memory, which is just an array of text prompts that the actor will then use when it tries to solve the task again. So you sort of can loop a couple times and you can keep this kind of like episodic memory to improve itself later on. It's kind of like an RL thing minus but instead of fine tuning it, or tuning the weights, you're storing these like memories. Um, yeah, so this is actor produces some like trajectory. This is like just an action it takes. Evaluator is gonna look at that and give it some kind of reward. And then the self-reflection is gonna take in that reward and the trajectory and build some sort of self-reflection string. Um, and then sorry, this should be the actor model, then uses a self-reflection string to produce the next action. And you can see here, so this is on the hot pot QA, and they're looking at like number of trials. That's something that these models go through to solve tasks. And then these different frameworks. So you have chain of thought. Chain of thought is like when you kind of, if you're doing an action, you give it examples of how to do that action beforehand. And React is another agent framework that's going to use tools. So I guess one thing I should mention is the cool thing about here is that actor, it could also be another agent framework. So it doesn't necessarily have to be another LLM. It could be a whole other agent framework. So in this case, they do that with React. And you can see here, like as you increase the number of trials, so it has chances to reflect on itself, it does a lot better um, over success rate or versus like chain of thought or versus this they're looking at adding the episodic memory. So I'm gonna go over this as an example. So in the paper, the way they do it for like hot pot QAs, your feedback is like you ask it a question, it'll give an answer, and then because it's a Q&A, you know the answer, so you say, nope, that's not the right answer, and that's the feedback, and it reflects on itself. But obviously, you don't have that in real life. So what I'm going to do here, I've modified the algorithm a little bit. You can find it here in the repo and Reflexion. So what what this is going to do is so when you ask the model a question, it's going to go through its regular framework. It's going to talk to the actor. The actor is going to have a thought. This is like an internal thing on how it's going to solve the problem. And then it's going to return a result. This is called an action, but in our case, it's just an answer to the question. And then I'm going to say, no, that's not correct. So I'm going to provide it with the feedback like you would in real life. And then what it's going to do is it's gonna first use another agent to see if my feedback, given my feedback, did it do the right thing or the wrong thing? In this case, it's going to be the wrong thing. And then we'll reflect. So it's going to basically take my feedback, reflect on itself, like what it did right or wrong. And then you take that, you add that reflection. And here we're calling it uh, this last scratch pad is kind of or sorry, reflections. So it's the thing that comes out of like that's our memory. Um, and then redo the same step. So what does that look like? So this is a little bit of a contrived example because you could probably do this without the framework, but just to kind of show it. So how many tires are on a truck? It's going to respond. And then I'm going to say, no, no, no. I mean, those trucks where they have like two tires in the back, right? The ones with two tires in the back and then one in the front. So it's going to be like six tires total. So let's just run this. And this is just using Chat GPT or GPT-4 Turbo as the agent here. So this is in verbose mode. So this is the thought it came up with. So it does seem to know that like there's some ambiguity in this question, right? So it says pickup trucks might have four tires. A big truck has 18 tires, and so it's going to guess 18 here. So that's the kind of action it took. And then you can see here, so I've responded with that, like, no, that's not right. And then this is going to be its reflection thought here. Let me know if you can see this. I'll make it bigger. My reasoning for the number of types failed because I incorrectly assumed the user was asking about semi-trucks. Um, and then it's going to come up with like a plan to improve itself. Um, and then finally here, so it gets the right answer, 6. So the reflection text here, and then it goes through the thoughts, but now it has this reflection text added. So kind of a cool idea. It's pretty simple, but I like the idea of keeping track of memory over time so that it can do some sort of improvement there. And the idea of like using natural language as a memory, I think, is pretty interesting. Um, whereas normally you might use some kind of like weird, vectors or embeddings to represent memory. Any questions on that one? Okay, cool. So this next one is called Easy Tool. And I think it's part of the same repo as Hugging GPT. If you've seen that, it's called this Jarvis repo. Um, Hugging GPT is actually a very cool, really cool tool. You can mess around with the demo. Um, they came out with Hugging GPT and then they came out with Easy Tool afterwards. And just looking through the code, I think Hugging GPT uses the same framework as Easy Tool, but definitely check out both. So um, this agent framework is now kind of taking on, a bunch of different components, right? So we saw like, actually probably not the memory component, but we saw the planning and the tool usage. And now we kind of have all those looped in together. So in this case, they basically wanted to make an agent that could use like a huge selection of different Hugging Face models. Um, and the way their framework works is they're going to have a task decomposition. So it's going to decompose the tasks. So decompose the question into subtasks, and then figure out the dependencies between the subtasks. And then you have a model selection part. So given a subtask, what kind of model am I going to use? And then you have a task execution. So, okay, given a subtask, a model, what are the arguments that I need to pass that model? And then finally, given a subtask, model execution. So I executed this model with this parameters and I got this result. You need something to summarize that into, what kind of answer you want. And then you also have like an overall summary agent for all the tasks. An easy tool is a little bit different than Hugging GPT. So one of the things they go over here is actually just how to document stuff. And they use GPT to document, to auto document a lot of these things. And it's actually pretty intuitive if you think about it. Like there's sort of two things you want. So one is a description of the tool. That's going to help you figure out, what tool you might want to use. And then the second one is basically just examples, which you absolutely would want in any documentation anyways if you were reading it, right? So they're going to say, hey, to use this tool, you need to pass in this thing. And here's like a scenario. Here's an example scenario of how to use it. Can you detect cats, right? If this is grounding dyno, yeah, pass the prompt cats to the tool. So they kind of talk about how they use GPT to auto generate these, but for our use case, we can just manually make them. It's not too big of a deal. And then you can run this, for those agents, you can use GPT or Chat GPT if you want. And you can see kind of how this can improve, different results. So here they're looking at GPT alone or GPT as using that as the LLM for the easy tool kind of agent framework. And this is kind of, as you bump up the number of tools, how's your, let's say this is the selection accuracy on the tools doing, or here, what's your naming error or parameter errors on the tool usage? How's that going? Um, and so we also have this, and I'm going to run through an example here. So Uh, it's gonna get this a little wrong because the tool gets it wrong, but I think this is a cool example. So this is like I don't know, a bunch of tomatoes, and there's some yellow tomatoes and there's some red tomatoes. And the question I'm gonna ask it, and so the just to give you a sense, the tools we're gonna have are access to grounding dyno for object detection, grounded SAM for instant segmentation. It's also going to have access to clip, and it's going to have access to some like basic calculator tools like add, multiply, subtract. And I'm going to ask it here. I have a bunch of questions, but this is the one. So I'm going to say if the red tomatoes cost $5 each and the yellow tomatoes cost $2.50 each, what's the total cost of all the tomatoes in this image? So in order to do this, you need to just make sure. Yeah. You got to use a bunch of different tools here. So I got it right this morning. Let's hope it gets it right now. This one's going to take a lot longer because this is going through quite a lot of different agents here. Um, but I'm printing them out here. So this first agent, a little bit hard to see, but it's taken that high level item and it's composed it into subtasks. So um, let's see. So it might actually see what it did here. So subtask detect objects as red tomatoes and yellow tomatoes. Okay. So it actually might get this wrong because I don't know if it can count red tomatoes and yellow tomatoes. Before, what it was doing two separate calls to grounding dyno, one for red tomatoes, one for yellow tomatoes. Let's see if it can count this correctly. Okay, 9 red, 14 yellow. That might be correct here based off of the tool usage. Uh, so, okay, interesting. This is kind of some of the problems I was running into before. So you can see here, it's made it's made a mistake. So it's done the first subtask correct, so red and yellow, and I don't want to verify right now, but I'm assuming it seems to be doing okay at counting. There might be 9 red tomatoes, 14 yellow. I could see that. That might be it's probably an issue with the grounding dyno tool. But then here, it's actually made a mistake. So it said count the number of red tomatoes by multiplying $5 by each tomato, but it's chosen the grounding dyno tool. So it's done an incorrect tool um, thing here. But it seems to have, despite doing an incorrect tool call, it looks like it was able to multiply it itself. It's kind of interesting. Okay, and then count the yellow tomatoes. So this is an issue I've been running into all morning. Yeah, so again, kind of odd. It's pick grounding dyno again. There may be some issue with our prompt, but it looks like the answer module was able to do this. I don't know if this is actually correct. Maybe someone can double check that 250 times 14. And then finally, the subtask here is add. Okay, great. So add is figured out the right tool here. So I'm going to add 45 and 35. Yeah, and that looks correct. So it's called the addition tool. And then finally, it's going to summarize the full answer here. And it's going to say $80. So based off of what it calculated, I think that's reasonable. I do think the grounding dyno does not actually it can't actually separate the red and yellow. So there's not 14 yellow tomatoes. But based off the tools it used, it was able to kind of do some of these tasks. Yeah, and you can see here, this, it seems to be doing okay. It seems to be struggling quite a lot with finding the right tool. There could be an issue with my prompting there. You kind of have to debug it and figure that out. So maybe I made a mistake there on prompting. Um, but you can see here that it's got choose tool. So it's really just it's taking a tool there, and then it's giving it I'm giving it this. So this is the user's question. That's going to be the subtask. These are the list of tools you have. And I format the tools. I basically take the description. I say ID 0 is grounding Dan. ID 1, that's grounding Sam. And you need to basically output some JSON with the ID of the tool you want. And so in this case, for whatever reason, it tends to choose grounding Dino quite a lot. So I've noticed as I play around with different sort of descriptions, it can do better or worse on this task. Um, maybe this one's kind of the more interesting prompt, actually. This is the choose parameters. So you can see they're pretty explicit, and you want this like JSON output so you can parse it to choose the parameters there. And yeah, that's it. So that's the two tool frameworks. You can also kind of see how this could be improved here by like looping in Reflexion as the one of the agents, right? So if you ran this subtask and you called grounding dyno and it failed on the call, why not just take that and reflect on it and say, hey, was that actually the right tool to call there? And it could probably loop back and call itself again and hopefully get the correct tool the next time.